Hello everybody and welcome back to the MMO project, where this episode we're going to be working on map spawning, specifically spawning in the map. I felt like I needed to clarify that. Also, I just noticed when we receive an updated desired position from the server, this no longer jumps the character a bit. We have dealt with that with our interpolation, so we can take that out of there. That is not necessary to have anymore, and I'm actually going to bump this down a little bit and also switch over to faster than light. Fantastic. Okay, so we're going to need to do a little bit of work on the server side. Not much at all, but last episode we put in the ability for the server to dictate to the client the actual size of the map, right? So we're going to put in the server knowing about that and telling the client what size it should be. So we're going to do a region const fields here, and we'll end that region. And inside of this, we're just going to do public const int min size equals 10. And we'll do public const int max size equals 10. And now we're not going to use this just now, but let's put in a public const int max height equals 6. Because once we're building this on the server side, as opposed to just on the client side, we're going to need the same information. So we'll just have that there. And then down here, we're going to have to put in our properties the way we have previously. So that's simply going to be a private int max, or rather map size x, and then we'll do a private bool map size x dirty equals true. And then we'll do a public int map size x. And then when we get that, we will simply return underscore map size x. And when we set that, we will set map size x equal to value. Sure, it'll put the space in for me. And we will also remember to set our dirty variable. So map size x dirty then equals true. Wonderful. We'll do the same thing for the y variable. So private int map size y. And that would be private bool map size y dirty equals true. Excellent. And then public int map size y. And here we will get our underscore, our private variable here. Wonderful. And we'll just return that. Return. Helps if I tell it to return it. And then we will simply set map size y equivalent to value. And then we will also set map size x, or rather map size y dirty equal to true. Okay, so those are set, but we also need to remember to check it in our dirty check here. So we will do or map size x dirty or map size y dirty. Excellent. And we'll also need to remember to set it when we set our dirty variable here. So map size x dirty equals, this is value. And then map size y dirty equals value as well. And then we'll need to remember to actually send it if it is dirty in the UDP message. And that I'm honestly just going to copy this tile set here. And we'll paste that in twice. And this will be if map size x dirty, then we will say map size x equals, and then that will simply pass in map size x. Wonderful. And then down here, same thing, but with y. So map size y dirty. Then this will be map size y equals, and then we will simply pass in our map size y. Fantastic. Okay, so now the server will create, or rather the server will send the map size, but this isn't being initialized to anything. So let's go to our map constructor here, and we are going to need to actually initialize these values. So int size x and int size y. Excellent. Then we're simply going to set this dot map size x equal to size x, and this dot map size y equal to size y. That will, of course, create an error in our instance because we call our map creation, which is, where do we call this? Right here, inside of our constructor here. That's fine. We can deal with that super simply. So we're just going to call random.next, and that's going to be map.minsize. And we're also going to call random.next, and that's going to be map.maxsize. There we go. So now we have a map size, and that is being communicated to the client, and the client is already parsing that out and knows about it. Fantastic. That should be all the work that we need to do on the server for right now. I'm just double checking. Yep, that appears to be everything that we need to do on the server for right now. So let's get rid of that. We do not need the server to be having its text open just now. But what we are going to need to work on pretty heavily is a couple of things in our various areas here. So the nav node, we definitely need to do one thing here, and that is when we declared this list right here of our connected nodes, we didn't initialize this. So we'll just say equals new list nav node. There we go. That's now initialized. And we are actually going to do the same thing in tile here, where our list of nav nodes, actually our list of nav nodes is generated here. So we don't need to do that in tile at all. We just needed to do it in nav node. Otherwise, when we ran it, this would be giving errors. And now that will fix that small issue. Wonderful. Now, one thing I did do is I moved our tile sets here, the enum, to our tile sets, or to our tile set script. It just makes more sense to me to have it there. So I'll just place it there for right now. And then in the tile set, I also want to have a reference to what tile set this is. So we'll do public tile sets, tile set. Wonderful, I typoed it. Okay, we'll do that. Now, there's a couple more things that we're going to need to do here, and I want to get them done before I forget. So first things first, let's hop into our map here, or rather into our representation manager. Okay, I've entirely forgotten where I did this. It should be in map. I think this is something I just added. I thought for sure that this was something that we had previously. Yeah, this is something that I added. Okay, never mind. We're going to come back to that. So, I do want to search for tile here, and I want to grab our tile prefabs, because there's one more script that we need to add on to this. We need an input object, just like that. Otherwise, when we click on them, we're not going to be able to start moving to them. So we'll need to do that, and of course that's not going to take height into account, and we're probably going to have to create a specific function for that. So that'll be interesting trying to do. We might choose like hit.point or something like that. And we also are not going to need this tile base. We are going to be spawning in new tiles. Wonderful. Okay, so let's hop back into our scripts here, and I just want to make sure, let's see here, under tile, we may as well go ahead and put in a new region here, and this will be fields. And we'll end that region. That'll be almost certainly expanded later, but for now all we're going to do is public float height equals 0f, and we're not really going to utilize that just yet, but for right now, we'll have that there. And then under the tile set, we already did everything that we needed. Excellent. So all of our remaining edits are going to be to the map script. Wonderful. So in this map script, we've got a lot of work to do. Let's go ahead and open up our updating here. So our from UDP message, I just want to make sure. Yes, I did make a change here. So we need to put in a new Boolean here. So underneath this here, we'll go ahead and do private bool rebuild map equals false. Wonderful. And then in here, when we receive any of these things from the server, all of these things, the seed, the tile set, the map size in either dimension, all of those changing means that we need to rebuild the map, right? So let's go ahead and do that by calling rebuild map equals true in all of these locations. We don't need to rebuild the map every time we parse one of these, but only when we're finished with the message. So once we exit this for loop, at this point, we are going to go ahead and say, if rebuild map, let's first check to see if we've got a map. So if map is not equal to null, then we need to go ahead and clear that map. Otherwise, we can just generate the map. And I'm not doing that in an else statement because we want to generate the map regardless. Excellent. So we don't have clear map or generate map implemented, right? So that's fine. We can implement clear map super easily here. And we'll just say if map is equal to null already, then we will say debug.log warning. We'll do this as a warning. Attempting to clear empty map. Aborting. Okay, and then that'll just simply return. If the map's already null, we don't need to clear it. Otherwise, we can say for int I equals 0, I is less than map size x, I++. For int j equals 0, j is less than map size y, j++. And then we will simply say destroy map I j dot game object. Wonderful. I was hoping when I put the semicolon in that it would put this space in for me, but it didn't. So I'll just do that. Now that doesn't immediately destroy it, it just flags it for destruction a little bit later on, so we don't have to worry about it corrupting the list or rather the array or anything. But we're just then going to set the map array equal to null. Okay, so there's our map cleared. We could, in theory, do some sort of object pooling here. Okay, there we go. We'll just mark that down for now, and we'll put this in the to-dos here. Object pooling for map regeneration. Okay, wonderful. But now we are going to start on the meat of this episode, which is the generate map function. So the first thing we're going to say is if map is not equal to null, debug.log warning, warning, generating map on non-empty map, clearing first. Theoretically, we should never see this, but I want to know if we're accidentally doing this. And then we'll clear map. We're not going to return or anything, we'll just clear it first, and then we will go ahead and reset the random generator. And that will be random equals new system.random seed. We'll seed it with that seed value that we got from the server. So we know that at this point, all of these are as up to date as they can be, right? So that's fine. So we'll seed that with our new random value. And then we'll say map equals a new tile array of size map size X and map size Y. And actually, I renamed these to have a capital S here because that's just the way I do it. So we'll do the same thing here. So we'll rename these to map with a capital S size X and map with a capital S size Y. Wonderful. Next, we will do an array of integers, a 2D array, and we'll call this map heights. And that's going to be equivalent to generate map heights. Without that capital E. Generate map heights. Excellent. Now, of course, that doesn't exist. So we're going to need to implement generate map heights. So let's do that right now. This is going to be a private function, or rather method, and it's going to return an array of integers, and it's going to be a 2D array of integers, and it's going to be generate map heights. And we're not going to take in any parameters here. Excellent. Now the way we're going to generate our height field is going to be with Voronoi noise. It's not necessarily the most realistic, but we're kind of going for a quasi-terraced look, and it's not going to be very smooth at the beginning. Let's get that out there. We're going to have to do a smoothing pass, and then we're going to have to determine what types of tiles that we need, and we're going to need to make a few new types of tiles too. That's all fine. We don't need to do that just yet. So for right now, we can say that our generate map heights is going to be a 2D array of integers. Map heights equals a new 2D array of integers, and that is going to be map size x and map size y. Excellent. And then we're going to do int Voronoi points, and our number of Voronoi points that we're going to use is simply map size x plus map size y. So for example, if it's a 100 by 30 map, we'll have 130 Voronoi points. If it's a 30 by 30 map, we'll have 60 Voronoi points. So that'll give us just like a kind of scaling amount of Voronoi points based on our map size. We can adjust that a little later on if necessary. But this is where it gets a little bit awkward because we're going to be storing these points as tuples of ints. So we're going to have a list tuple. There we go. Int. And we're going to call that the Voronoi list equals new list of tuple int. Excellent. Why is this currently not finding that namespace? That's in, I believe, system. So yeah, using system. That's fine. Boo.lang. We're not using boo.lang. It did that to me previously as well. And the reason was because it couldn't find the list. So we're just using system.collections.generic. There we go. We want to use the list from there, not whatever is in boo.lang. I don't know what's in that, but... Okay, so we've got our list of tuples here. That's wonderful. And we're also going to declare a tuple int point. Excellent. So that's what we'll need to generate our map heights. And for now, we will simply return map heights. Just so that it compiles. Excellent. Now we're going to need to do essentially two passes here. We're going to need to do an initial Voronoi seed. And we're going to say, while Voronoi points is greater than 0, 0 in the random.next. So like when we do random.next 0 map size x here in a moment, the 0 is inclusive and map size x will be exclusive, which is exactly what we want. This is exactly how it works in Unity as well. So that's fine. So our point is equivalent to new tuple of type int, and this is going to be random.next 0 to map size x. There we go. And our maximum is going to be random, or rather our second tuple is going to be random.next, and that is going to be from 0 to map size y. Wonderful. So if our Voronoi list contains, not count, contains our point, then we've already seeded this. I still want to say Voronoi points minus, because I want this to take a consistent amount of time. I don't want this to take, if you get terrible luck and generate like the same points over and over again, I don't want this to be any longer. So we're still going to deduct the Voronoi points, and then we're going to continue. Otherwise, we are going to say map heights point.item1, which is of course the first int in the tuple, and point.item2 equals random.next, and we're going to go from position 0 to max height. Excellent. So that generates a seed point right there. And of course, the name max height does not exist, so we're going to need one up here. So let's just go ahead and create ourselves some const fields. So we'll do a region const fields. Excellent, and we'll end that region. And so we'll do, actually 4 of these is what we're going to need. So we'll do a public const int max height equals 6. Wonderful. So that can return anywhere from 0 to 5. So there are 6 total heights, 0, 1, 2, 3, 4, and 5. Perfect. We'll come back to the other const fields as we need them. So we'll go back to generating our map heights here. So now that's in, and we can do Voronoi points minus minus, so we'll subtract 1 from there. And then we'll do Voronoi list.add our point. Excellent. So we'll keep track of our points there. And then once we're done with that, then we can do our Voronoi sampling. Wonderful. We'll just iterate through the 2D array at this point. So for int I equals 0, I is less than map size x, I++. And then for int j equals 0, j is less than map size y, j++. Why did I put a comma up here? There we go. Excellent. So we're now iterating through our 2D point here, and then we're going to need to do a tuple int point equals, or rather, we'll call this nearest Voronoi point equals get nearest Voronoi point, and we'll pass in a new tuple int, and that is of course going to be ij. That is our point, and we'll also pass in our Voronoi list. Now of course, get nearest Voronoi point does not exist, so let's go ahead and put that into our map utilities here. I'm just going to put it underneath find nearest tile from position. This is going to be a private because we're only using this within this little subsystem here because it uses tuples rather than any of our other things, so that's fine. We'll make it private. This will be a tuple int that it returns. Get nearest Voronoi point. There we go. It of course takes in a tuple int point. And it also takes in a list of tuple int Voronoi points. Excellent. Okay, so we'll need to do this basically the same way we have been with all of these get nearest. And so we'll do int best dist. This will all be integers, so we don't need to do any floating point math here. Int best dist equals int.maxValue to start with. And then we'll do a tuple. This will be int best point equals, and we'll have this default to Voronoi points 0. And then we'll just return best point so that it compiles up. Wonderful. And now we'll iterate through our list for int I equals 0, I is less than points, dot count, I++. And then we will say int diff is equivalent to mathf.abs, so we take the absolute value of point.item1 minus Voronoi points i.item1. And then we'll add to that the absolute value of point.item2 minus Voronoi points i.item2. Excellent. That'll get us the Manhattan distance to the point in question. And now if our difference is less than best distance, then our best distance is at that point equivalent to diff, and our best point is equivalent to Voronoi points I. Excellent. So that gives us our nearest Voronoi point, and we can utilize that right up here, and we already are. So that gives us our nearest Voronoi point. Wonderful. And then all we need to do is say map heights ij is equivalent to map heights nearest Voronoi point dot item 1 and nearest Voronoi point dot item 2, because those tuples are just coordinates on this grid. Perfect. So that gets us our map heights. Wonderful. So we now have our list of map heights, and we can now utilize that to instantiate our actual tiles. Now we're going to do this very basically right now, okay? We're just going to put out the base tile, and we're just going to instantiate it at its correct position and rotation. We are not going to be doing anything with smoothing or figuring out what tiles should actually be there just yet. So we're just going to do for int I equals 0, I is less than map size x, I++. We'll need to iterate through both dimensions here. For int j equals 0, j is less than map size y, j++. We'll simply say map I j equals instantiate, and we're going to instantiate tileset.baseTile, which apparently doesn't exist. Okay, we'll come back to that. The position that we're going to put this at is going to be a new vector 3, and this is going to be tile width times I, which doesn't exist yet. So let's actually go ahead and implement what we've got here so far. We'll need to put in our tile width, which is just going to be a public constant. Tile width, and that's going to be equal to 3. We'll also do a public const int tile height, and that's going to be equal to 3. And we'll also do a public const int, actually this will be a float, tile height. Oh, this should not be height, this should be length. We've got width, length, and height will be 0.8f. That's the height that we determined in Blender was the height that we wanted. Okay, so that gives us our const fields there. Now, we still need to implement this base tile here. Or rather, tileset.baseTile. So that's fine. We will go ahead and put ourselves a public list of tilesets equals new list of tileset. And this is going to be, instead of a public tileset, it's going to be public tileset. So we're going to be using the class that we created instead of the enum. That, of course, creates an error right here where it can't cast an enum to a class. So we'll fix that easily enough by calling get tileset, like so. And we'll just do that. Wonderful. Now, of course, get tileset does not exist. So we'll need to implement get tileset, and that's easy enough. We'll do that pretty much right underneath update map. So we'll do public tileset get tileset. That'll take in a tileset. There we go. And we'll just iterate through our list of tilesets. So for int I equals 0, I is less than tilesets.count, I++. If tilesets I.tileset equals tileset. Now, tileset doesn't have a tileset, so we should probably tell it about that. We'll hop in over here, and it's tilset. I typoed it. Yeah, we'll put that in there. I thought I had done that, but yeah, I typoed that. That's okay. We'll fix that now. And then I'm missing a curly brace. There we go. Then we'll do a quick return tilesets I at that point. Otherwise, we will return no. Wonderful. So that gives us our tileset. Now, of course, we need to actually have this list be populated. For right now, we only have the one tileset, so we'll hop into map here, and we'll go into our tilesets here. And, oh, right. It's not going to compile up yet because we haven't finished this line. I suppose we can finish this. Okay, so that's going to be a new vector 3 tile width times I, and then we're going to do tile height times map heights ij, and then we're going to do tile length times j. Excellent. And then we are, of course, also going to do a quaternion.Euler, and we're going to have to pass this in at a new vector 3. Actually, want this to line up. Okay, so we'll do a new vector 3 here, and this is going to be 270, 0, 0. In my testing, that's what we needed. Okay, so what do we got going on here? We need that parenthesis to not be there. Now we need an extra parenthesis at the end, I believe. Yes, we do. There we go. No issues found. Wonderful. So we're instantiating that tile now, and that is actually our generate map, at least for now, done. We are not done with that overall, but for now, that's done. So we'll need to put in our tile set into our list of tile sets here. And so we shall, just like that. And now, if we fire up the server, this is not the server, if we fire up the server, and also the client, oh, the server took a long time to fire up there. There we go. And now we wait for the questionable amount of time it takes to do the encryption handshake. There we go. That wasn't too bad. We'll go ahead and log in, and we'll enter this world, and you can see it created us a little tiny tile set here. 1, 2, 3, 4, 5, 6. Well, that's interesting. It created it 6 by 4. That's... What did I mess up here? I messed something up here. Clearly. When we are initiating this... Oh. I'm a moron. Okay. Yeah, I'm an absolute moron. This needs to be random.next map.minsize map.maxsize, because it was just going from 0 to the minimum size and then from 0 to the maximum size. So we're going to stop this server here. And we're going to do, this needs to be min size, and then we need to do map.max size. Okay. That will get us proper sized maps. Let's fire up our server now. Excellent. And we will fire up our client as well. We'll wait for the encryption handshake. And now it should generate at least a 10 by 10 map. A 10 by 10 will still be very small, don't get me wrong, but it can go all the way up to 100 by 100, and it'll likely be larger than 10 by 10. So we'll log in here. Excellent. Now you can see it placed us underneath the surface, and this map is definitely still a little on the small side, but if we tally this up, let's see here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is exactly the minimum. Uh-huh. That's interesting. Let's try rerunning that. Because previously, I mean, it's theoretically possible that it gives us a 10 by 10, right? But it's pretty unlikely that it gives us a 10 by 10. Maybe I messed something up. Let's rerun that and see if it's any better. And of course, that's being provided to us by the server. That looks also 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's still 10 by 10. Random.next takes the min value and the max value, so we go from map.minsize. Did I typo this? I did. The max size needs to be 100. That'll solve that problem. Okay. Yeah, I know the server connection was interrupted. It's because I started up the client before I started the server. Okay, server is up, and let's go ahead and run this. In theory, it shouldn't take anywhere near this long, and in practice, this is mostly an editor thing. Based on what I was reading when this is compiled and actually built, it won't take that long, so that's what we're banking on right now. But for right now, we'll just, that's not how you type. There we go. We'll get logged in, we'll enter this world. This is more like it. Fantastic. So this height is of course generated via Voronoi noise, and we're going to need to run some smoothing on this so we don't see things like this giant cliff. I'd rather see a series of smaller cliffs terraced up. Of course, we'll only be able to climb it in certain circumstances. But we're going to need to put in the ability to do ramps. We're going to need to, and in fact, every area should, in theory, be accessible pretty much. So we're going to need to figure out all of the connected tiles, like all of the little islands here, and make sure that they're all connected via ramps and smooth them out and determine what actual tiles to use rather than just this basic tile. But you can see that because we made them into input objects, we can click on them and we will start moving to them. That's wonderful. However, if we click up here, you'll notice we walk right below it. Well, that's because we're assuming that our input object is all at height 0. That is something that we can fix, but it is not something that we are going to fix immediately. It's something that we're going to fix soon. TM. But hey, that's a start. We've got an actual map generating, and it's different every time because we get a seed from the server, and we should be able to generate this exact same map on the server utilizing the exact same code, which is good because we're going to need that for things like collision detection and pathfinding on the server. Fantastic. So the server map is of course going to be quite extensively modified, but that won't happen just yet. So that is map spawning complete. Next, we are going to do map smoothing and, well, maybe just map smoothing and if time. So we'll do map smoothing, and if time, we will also do tile choosing. Ramps. Okay. Tile choosing, ramps, water. Excellent. And with that, I think I'm going to go ahead and put a cut in here. That's pretty decent progress for today. I'm pretty happy with that. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time when we work on smoothing out that map.